Saya pun dapat sama teacher.
Okey, sama. Fakrul? Fakrul?
Sama je.
Sama? Ya ni? Sama Okay, let's see. Okay, volume to be maximized. So you got the formula of volume 12 minus 2x, 12 minus 2x and multiply by x, the height. So you got this formula of the volume and then we differentiate the volume equal with 0. Then you're going to get your x is 2 and x is 6. There are two answers here. But then what? You differentiate, do the second derivative and then substitute. When x is 6, we will get negative value. Yeah, so kalau negative value meaning that positive and negative 96, but this is positive greater than 0. So V is minimum when x is 6. And then you substitute x equals to 2 into your second derivative, the value is negative. And that one will give you the volume maximum. Yeah, when x is equals to 2. Kita confirmkan ya. So the area of each square to be cut from the corner is 2 by 2. Okay, alright. Okay, this one class, I give you this question.
No, teacher.
No. Okay, belum. Okay, sekejap. Boleh cepat try. You have been asked to design a 1 liter oil can shaped like a right circular cylinder. What dimension will use the least material? Okay, alright. Siapa nak cuba? Who wants to try? Anyone? Siapa nak cuba?
Saya leceh.
Okay.
Volume
Alham.
volume 1000 kan.
Volume 1000.
H kita derivekan H daripada pi r square H.
Apa dia? Again?
Derivekan H daripada volume tadi. Pi r square H
Volume.
equal to 1000. And then
Pi r volume is
pi r square h.
pi r square h. So h you derive from
V ni 1000 and then kita boleh
equals to 1000. Okay, so h is equals to
1000 over
1000.
pi r square.
Okay, alright. Good, next.
And then kita ada surface area punya formula 2 pi r square
Surface area, which is 2 pi r square,
plus 2 pi r h.
2 pi r h. Okay.
And then masukkan nilai h dalam tu.
Okay, so you will get what? Cancel this, and r can. So
2000 over r.
2000 over r. Okay, next.
And then we bagi dapat r, we equate
Bagi apa?
this, we equate this to 0 after we differentiate.
Okay, you differentiate this with respect to r lah, kan?
Yes.
You differentiate, you get what?
4 pi r minus 2000 over r square.
2 pi r minus 2000
4 pi r.
over, oh sorry, 4 4 pi r minus 2000 over r square. Okay, and then
My r
equate
value
with
is
0, your r is
5.43. 42.
5.42.
42.
One value only?
Ada yang belakang dah bunda.
Tak, maksudnya R ni satu nilai je, 5.42.
Kita calculator je.
So,
And then we have to insert that back to get h.
get H, okay, substitute here, then your H become
10.84.
10.84. Okay, is that all?
Yes.
Okay, macam mana you confirm ini adalah ia yang akan jadi minimum?
After yang first punya differentiation, buat yang second punya differentiation and then insert 5.42. And then nilai dia lebih daripada 0, positive value.
Okay, so make sure you have to do that. Ya, jangan skip ya. Otherwise you will lose some marks there. Okay, alright. So this kita tengok ya. Okay, so like Arham said just now, that's the method ya. Differentiate and then equate with 0, then you got your R is equal to about 5.42. Ini pun samalah. Tapi I told you just now, mesti check this 5.42 ni will give you the minimum value bila you prove this using the second derivative. Masukkan dekat second derivative ya. Alright, next class, last one. After this example, we move to the integration. A rectangle is to be inscribed in a semicircle of radius 2. Yeah, and then what is the largest area the rectangle can have and what are its dimension? Ni macam the same question I gave you earlier, but this one we can see we use the equation of x square plus y square equals to 4. Okay, how are you going to get this? Okay, done? Class? Who wants to try?
No, teacher, tak ada lagi.
Again?
No, teacher,
Boleh.
tak dapat lagi.
Tak dapat lagi. Okay, I give you some ideas here. Kalau tak nampak, the x square plus y square equals to 4 ni because of this. From here to here is your x. From here to here is your y. Kan? So kita guna theorem Pythagoras. Yang ini adalah dia punya radius. Radius is 2. So that's why we have here x square plus y square is equals to 4. Yeah. So from here, kalau kita tahu dekat this point, this is x. So definitely your y become set 4 minus x square. Manipulate lah ni. Right, so y square is actually 4 minus x square. So y is equivalent to this. Set 4 minus x square. Ini yang kita dapat from apa yang dia bagi ni. This is the coordinates of this point. Okay. So anybody would like to try? Class, come on. Yeah.
Teacher,
Yes.
kejap. Kejap teacher. Masih menekan but dia nak from what I got from what I got is the maximum at 0.816 teacher.
Meaning your x. Maximum when x is yeah.
At 0.81.
So
Higher
x
teacher.
is 0.8. Betul?
0.816.
6
I got
lagi.
x is at 0.816. So
Again?
for y,
Y.
so y is y is 1.83.
1.83. Okay, let's see the answer, yeah. Okay, as usual, we want to see the area of the rectangle. So area of the rectangle definitely 2x times y. Yeah, kalau kita tengok our diagram here, this one become 2x because of half of this is x, kan? This is x, from here to here is x. So from here to here is definitely 2x. So x and x to x. And this is your y just now. Right, so from here, okay, so from here we can see that the area of the rectangle is 2x times y, where our y just now we got it set 4 minus x square, right? And we know that x always positive, so we differentiate this to get the minimum or maximum, kan? Alright, so we got this. When you differentiate, ataupun the easier one, you boleh square lah both side, kan, to eliminate the square root here. Okay, so equate with 0 here, we're going to have your x is plus minus 2. Adakah plus minus 2 is 1 point something? Tadi Ayub 0 point something, Ayub? Set 2 is 1.414. Tak sama, eh? How did you get your answer just now, Ayub?
Oh, I think I made a mistake, teacher. For the area I did 1x and 1y rather than 2x and 2y.
Yeah. So that's the mistake lah. Yeah, supposed to be 2x times y. The length of the x to double. Okay, so from there you're going to get your x is plus minus 2. Okay, so from here we do the second derivative again. And then we're going to get substitute when x is equal to set 2 into your second derivative, you're going to get this negative 8, which is less than 0. Yeah, so kalau dia less than 0, meaning it will be a maximum. And if we substitute positive set 2 dapat apa? Ini positif lah. Yeah, so it's going to be this. Okay, dah habis. Saya tak tunjuk kalau kita substitute negative set 2 ni. Class, let's see. If you substitute the negative set 2 ni, what happen class into your second derivative? Negative set 2. This one become negative again, tapi negative here become positive. So it become positive, right? If you substitute the positive set 2 into your second derivative. Sorry, negative set 2. Yeah. And then one more thing, of course X cannot be negative sebab X adalah dia punya length kan. So definitely it's supposed to be positive set 2 and it shows here when we substitute the set 2 into your second derivative, it gives us the maximum point, negative value. Yeah, so the maximum will be this lah. Yeah, X is apa? Set 2. Ataupun kita boleh tulis dimension dia ya. It will be good if we write the dimension 2 of this lah. Twice of set 2 X kan. Okay. Twice of set 2. Okay. Twice of set 2 multiply by set the Y 4 minus 2. 4 minus 2 sebab dia X kan. 4 minus X square. So this is set 2 square is 2. Okay, so 4 minus 2 set 2 lah times set 2 lah actually. So 2 set 2 times set 2 kan. 2 set 2 the dimension times set 2. This is the dimension. Okay. Alright. Class, so far any question before we move? Ada soalan tak? I guess you got no problem. Okay, good. So please practice dia punya ni optimization ya. So now I'm going to proceed with our last chapter in IB syllabus is the integration. Hold on, I'm going to share my slide. Okay, so today it's just a brief idea apa macam mana dia we got the integration yes. Yeah. Yeah. Okay. Actually you have learned the integration in SPM level kan? But again, we just recall it back here and we will do some application on this later on. So kinematics tu kalau you tengok in your textbook, kinematic under differentiation, but I still not discuss about that because I think it is good if we cover the integration then only we discuss the kinematic sebab kita boleh tukar. Okay. Let's go. The integration is approximating the area under a curve. So we are looking for the area. Okay. So if you are given with this function y equals to x squared, a quadratic function, and the domain given is from 0 until 1, x here. So we want to look at the area under this curve yang pink shaded area ni. Okay, so this is the idea. We consider the function and we are going to estimate the area, which includes by the function x-axis and also the line x equals to 1. Okay, so ni lah. Okay, kita ada ni. This is the function. Okay, and then we are going to get x equals to 1 is here. Tak lurus and then your x-axis is here. So we want to get this area, okay? And suppose we divide the interval here from 0 until 1 here, into 4 strips with 1/4 units, okay? So we are going to get 4 strips. So this is the first one, second, third, and the fourth one. Kita divide this into 4 strips. Okay. We just want to get the idea first, yeah. And then from here, okay, look, we have rectangles. So here we build the rectangles, right? Sebab this one, the 4 strip that we divide just now, 1 divided by 4. Yeah, each of these definitely kita ada size dia ni berapa? Definitely if this is 1/4, kan? So from here to here is 2/4, yeah. Here is 3/4. But the size here is all 1/4, 1/4, 1/4, and 1/4 here. And we managed to draw the rectangles here with height equals to the lower value of the function. Okay, all right. And the endpoints of the sub-interval. Okay, all right. So maksudnya apa? Rectangles kita ni, dia punya lower value of the function. So this is, kalau kita tengok this one from here, okay, at the endpoints of the sub-interval sampai sini. Ni endpoints dia lah. From here until here. Yeah, okay. Alright, the total area here, yeah, the total area of the lower rectangle. Okay, kenapa kita panggil dia lower rectangle? Because later we will compare this with the one is upper rectangle. Yang ni kita panggil lower because we measure from the left side here. Yeah, here 1, 2. Yeah, the lower part of the rectangle. So the total area of the lower rectangle is, we are looking for the area of the rectangle, each of this. So for the first one here, okay, saya tengok ya. For the first one here, this is, the size here is 1/4 multiply with the function f of 0. F of 0, this is the function. Yeah, okay. So plus 1/4 times 1/4. Yeah. So this is 1/4, yeah, time with the lower function here is 1/4 here. Okay, and then same goes to the next one, 1/4 times 1/2 here, yeah, and ni pun, and the last one here 1/4 times f of 3/4. Memang dia ambil yang lower function, yeah, sebab dia ambil yang lower parts of this, the rectangles. So we substitute, we got this value 0.21875. Yeah. So nilai ni digunakan the function lah x square, kan? So when x is 0, is 0. When x is 1/4, this is become 1/16 lah, 1/4 square. This is 1/2 square, 3/4 square. Sebab kita punya function fx is equals to x square. Okay, all right. So from here, class, we move to the next one. So this is the upper rectangles. Okay, kalau you notice, just now we use the lower rectangle. Now we use the upper rectangle. You see here, okay, just now the graph adalah the rectangle here is below the function line, but now it's above that because we look at the above rectangle here. Kan, this is the rectangle, the above one yang touch the function. This is the touch the upper parts of rectangle. Okay, so the rectangle with height equals to the upper value of the function. So height ni, the height dia, no, okay, is equals to the upper value of the function. Yeah, so this is the function, the upper value. Yeah? So ni pun sama lah here. Okay, and here also here. Okay, alright. At the end points of the sub-interval. So macam biasa juga lah. This is 1/4 just now, 2/4, 3/4. Yeah, so dia ambil the upper rectangle. So the total area of the upper rectangles, if we use this, yeah, kalau kita tengok ni, kalau kita consider this one, okay, we are going to get this. Yeah, so again, we are looking for the area of the rectangle here. So we will get this. Kita akan dapat ni lah. 1/4 times your function when x is 1/4. Sebab kita ambil the upper rectangle. Yeah, 1/4 is the length here. And then the second one is still 1/4 because from here to here, yeah, multiply the height of the rectangle. So height dia memang kita ambil yang ini and touch the function. Okay, is when x is 1/2. And then the next one is this one is also 1/4 times the height of the rectangle here when x is 3/4. Yeah, f of 3/4. And then the last one, this is also 1/4 times the height of the rectangle here when x is 1 is equals to 1. So substitute, we got this value. Okay, alright. But actually class, kalau you think the actual area, it will be a bit different ke tak? Sebab kita yang macam ni, kita tak consider yang extra ni. Kalau we compare yang the previous one, okay, there's still, kalau kita nampak sekejap ni, if we compare this one, ini, we miss this area. Dia ada yang area yang tak cukup ni, betul tak? Okay, ni, this part. Kan, sebab kita ambil area yang apa, this is lower part. Kan, kalau yang ni pun dia akan ambil lower part. So ada yang tak, yang we don't calculate that. So that is not exact lah. So kalau kita guna the upper also, upper rectangle also, it's just an estimation. Yeah, it's just an estimation. Okay, sekejap. Okay. This is the upper part just now ini pula yang lebih ni. So that is the total area. So from here class, yeah, we can see here for increasing functions such as the x squared, the quadratic function, the area tu is actually the total area, the exact area is actually between the area of the lower part of the rectangle just now and the upper part. It must be in between. So the area A lies between 0.218 and also between 0.468 something just now. Yeah, sebab that is the total area exactly. Okay. If the interval of x is between 0 and 1 was divided into 8 sub-interval instead of tadi kita ada divided by 4, now the width become 1/8. Right. So when you divide this with 1/8, we are going to get this area. Kalau guna the lower part is 1/8 when f0, f1/8 and so on. It's the same method and then we look for the upper parts of the rectangle. Sama the same method, but just now is you have 4 strips, now you have 8 strips, divided by 8. So the area is become this 0.39844. Cuba you tengok yang atas ni tadi. Our area tadi is actually between 0.2 something and 0.4 something. But now, if you divide into 8 strips, the area is between 0.273 and also 0.398. A bit different lah kan? Kan? Dia punya nilai berbeza. Okay. Alright. So class, kita boleh cakap now, the area lies between 0.27344 and 0.39844. Okay class, if you want to get it more accurate other than this, you can divide the x just now into smaller parts. Jadi kita akan dapat dia lebih dekat because okay, you just imagine if we got something like this. Okay, katakan this is our curve just now, right? So kalau you divide hold on. Tak jadilah curve saya ni. Lebih kurang lah Dia sepatutnya macam sampai sini lah kan. Okay. Okay. So if you divide the X here into a smaller parts, so ni 1 tadi kan. So kalau you divide by, katakan by 20. Jadi the size tu dia akan jadi lagi kecil. You akan got 20 strips, 20 different strips. Kan? Therefore, dia akan reduce the area yang bila kita tengok kalau kita buat dia jadi rectangle tadi. So you will reduce yang sepatutnya kita tak kira tu. You will reduce. So if you make it larger, your X larger, bukan X, N ni. Kita divide by N tu. How many, what is your N? Just now your N is, the first one is 4. Now N is 8. Now I give my example, my N is 20. So dia jadi lagi kurang error. Less error. Because it become more smaller kan. It becomes smaller and the calculation better. Yeah. So that is the idea of this. Okay, let's see. As I told you just now, as we create more sub-interval, the estimates of area of the lower and the area of the upper will become more and more accurate. In fact, as the sub-interval width is reduced further and further, both the area of the lower and the area of the upper will converge to A. Yeah, so kalau you semakin rapat, so it's converged to A. Okay, class. That is the basic idea of kita punya integration. Now, there are n sub-interval between x equals to 0 and x equals to 1, each of with 1 over n. Yeah, you can use the area under finder software of your graphic calculator to help to calculate the lower and upper for large value of n. So now class, I want you to try using your calculator to get this value. Kalau kita tukar n kita ni, tadi we have example 4, 8, alright. Can you try to get the value here, 16, 50, 200, 1000 and 10,000 to get this average value? Okay, cuba kelas. Use your calculator. Okay, how to do this? Our function just now is x squared. Okay, class, how to do this? Okay, let's use our calculator. We go to, definitely we need to open our calculator page, yeah. Okay, and then press menu and then select calculus number 4. Class, are you with me?
Yes,
Yes.
teacher.
You can follow my instruction.
Yes, teacher.
Okay, yeah. So press menu just now and then select number 4, the calculus, and then select number 3, sum. Okay. So now we have this. Now we are going to calculate the lower sum first, yang kita ada AL ni kan. Okay. Cuba tengok. Here, we want to calculate this value. So how are we going to do this? And our function just now, our fx is equals to x squared. Now our n is this value. So how are we going to do this, class? Okay, cuba masukkan. Bila you dapat in your calculator tadi, yang saya suruh buka tadi, the lower sum. Did you get this sign? The sum of whatever we want to substitute here and ni kan, ada kotak sini kan, equals to what until what, right? You get that?
Yes, teacher.
So kita masukkan So this one we put it as your x lah. X is equals to, kita begin with 0 lah because our graph just now x kita begin with 0. Something like this kan. So this is our x begin with 0. Okay. So we put 0. Okay. So how this one? Our function is, if we think about our rectangle just now, kan? Okay, katakan kita ambil yang lower lower, so yang ini, and also this one, the lower parts. Okay, lower rectangle. So the size here definitely, kalau yang ini kita buat the first one 4 here is what? 4 lah kan? Betul tak? Ni kita tengok this one is 1/4. This is 2/4. 3/4. 5/4. Ya, ini sampai 5/4 pula. 4/4, which is 1 lah. This is 1. Okay, so we begin with x equals to 0. Ya, so kita punya area of this rectangle adalah, the area of this rectangle, let's say this one, the size here, the width here is 1/4, and the height will be times, this is x square kan, y kita, right? Betul tak?
Betul, teacher.
Number 4.
Okay, so we have x over 4 square. Right, our y just now. Okay, so kita punya x ni class, we want to see here, this is 1/4, 2/4, 3/4, 4/4. So kita nak tengok sum dia. How many? Kalau the first one ni, we got no triangle, right? So this is the first one, second, third, and definitely here lah. Ada tiga triangle ni, right? So we will have x equals to 0 up to 3. Yeah? Okay. So we substitute this function here. 1/4 times x over 4 square. Sebab ini adalah x square kan? Tapi kita divide by 4. So cuba masukkan into your calculator. This is actually 1/4. Times with x over 4 square. And above there, we're going to have 3. So the sum, enter, we are going to have 7/32, which is 0.21875. Dapat tak ni? This is the first one class. Kalau you masukkan ni, you
Teacher,
will,
kenapa 3?
yes. Kenapa 3? Sebab the first one here, kita ada 3 rectangles only. From 0 until 1. Okay, I'll show you again. I'll show you again my previous, yes, sekejap the diagram here. Nampak tak ni? Ini bila kita, we want to find the lower parts here, right? Nampak tak? Kita punya diagram ni, we only have 3 rectangles only. Kalau you nampak kat sini, sekejap saya okay. If you see here, nampak tak ni ayat? 1/4 times f equals to 0 sebab kita ambil dekat lower rectangle. Untuk the first one here, you see here, this is 0. You see that? The second one here, This is 1/4. 2/4, 3/4. So the second rectangle here is this 1/4 times f of 1/4. Sebab kita ambil lower parts of the rectangle yang dia touch our function. So sebab tu untuk the second one is 1/4. 1/4 tu dia punya width. The height ni adalah height tu kita ambil yang height yang dari tepi ni, yang touch our function. So ini function kita kan x square. Bila masa x is 1/4, that's why f of 1/4. Got this. And then the third rectangle, height dia adalah here because we consider lower rectangle. Kan? So the height is here. So height dia is here, x square. When x is 2/4, which is 1/2, 1/2 square. Ni, nampak ni? And the last one, the last rectangle here, the height is here. Sebab tu kita ada up to 3 only. 0, 1, 2, 3. Nampak tak ayat? Kelas.
Ayib terkeluar teacher.
Oh, dia dah terkeluar. Okay, so the rest of you, is this okay? That's why in the calculator tadi saya suruh you substitute x equals to 0 sebab x tu begin with 0 sampai 3. Right? Yeah? Okay. So kita masukkanlah kita punya function ni 1/4. Right? Kan? So yang ini saya tukarkan kepada x/4. Sebab apa? Sebab ini adalah, nampak tak yang square kat sini? Ini adalah you punya height. Height dia x square. Tapi saya masukkan sebab kita ini adalah, I refer our x here as 0 here. This is 0/4, 1/4, 2/4, 3/4. X tu adalah yang ni atas ni 0, 1, 2, 3. So x is equal to 0. So x ni kita nak sum of all this area. So maksudnya when x is equal to 0 here, so this one is 0. So kita akan dapat ni. And when x is equals to 1/4 here, the height of the second rectangle here is 1/4 lah. Kan? And then when x is the height here, the third rectangle, 2/4. So ini pun akan jadi 2. The last rectangle here is 3. So that's why here become 3. So that's why I ask you to get the summation of this one from your GDC just now. Faham ke tak faham? Kelas? Faham Okay, kalau faham, I just want you to play around with this. Saya nak you cari the area gunakan formula by GDC tadi. Sekejap. Saya buka yang tadi. I want you to complete the table just now. Ni. Yeah. Yang I put all the question mark here. Okay, so I want you to complete all this using your calculator untuk n equals to 16, 50 until 10,000. Untuk the area of the lower rectangle, area of the upper rectangle, and we want to see the average. Can you do this as your homework? Yes or no?
Boleh teacher.
Yes. Okay, so please use your calculator. Use the summation punya apps tadi, ya, to key in and get the answer. Jangan susah-susah, pakai calculator. Okay? So create the formula as I told you just now untuk cari dia punya sum of the area. Okay? So I guess I have to stop here. It's more than 8:50 already. Okay? Alright, so let's send Mr. Speak Kafara and Surawalas.
Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Al-asr al-insan min syarri alladhina amanu wa amilus salihati wa tawassaw wa tawassaw.
Okay, Assalamualaikum.
Thank you teacher.
Teacher.
Teacher.